Hey, good morning. Happy Thursday, guys. Um, Sixth graders, this is our geometry. We're talking about triangle area, and that's what we've been talking about, parallelograms and triangles. And yesterday in class on Wednesday, we focused on, let's see, what did we focus on? We focused on practicing the triangle thing, and what we talked about the formula again and how we use it. And really interestingly, actually, I want to see if this thing jumps back and forth. Let me see if this works. Okay, it does. Up. Let's see if my face comes up. All right, this will work. This will work. Okay, making sure right away. All right. All right, here we go. So the area of a formula or area of a triangle, any triangle, can be calculated through the formula, and we're going to put it up here. The formula of area, okay, the area equals base times height divided by 2. Okay. And the part that everybody always forgets is the divided by 2 part. So that's really important. So remember that dividing by 2. And the reason we know that is that a triangle is half of, or a triangle is half of a rectangle. So if I look at this one right here, like this triangle right here is half of the larger rectangle. So like for instance, if I draw that rectangle and do the length times the width, the part of it that's the triangle is just this half of it, right? So that's why we divide by 2. We find the base times the height, divide by 2. Okay, now I want to talk to you about this problem. So our problem, Xiomara's triangles are these 3 triangles. And what they ask you to do, or what I ask you to do in the problem, is solve for the area of this triangle. This would be the right triangle, right? And we know it's a right triangle because it's got a right angle here, 90 degrees. And then I ask you to find the area of the isosceles triangle. Now, in both of these, what you need to do is you need to find the base and the height. So we first need to identify the base. So this is the base, right? And then we need to identify the height. Neither of those things are very complicated, right? So that's the base times the height. So base times height, which is the same as what you do when you do, like a parallelogram or a rectangle. You're looking for the perpendicular base and height. No problem, right? So we can do this. And remember, the base and height always want to line up. So like in this triangle, even though the orientation is flipped, meaning that I see that right down here and right down here are the sides that I'm going to be looking at, this side, it's like the base doesn't always have to be on the bottom. Like, for instance, on this one, that can be the base. Or we could say that this is the base. Either one's fine. You just have to make sure they're perpendicular to each other. Perpendicular, right? Perpendicular, right? 90 degrees, 90 degrees. The height is always 90 degrees from the base. So this is triangle 1 right here, right? No problem. This is triangle 2. I'd like you to actually calculate them, explain how you did it, show your formula. No problem. The third question says, find the area of the scalene triangle, the non-right scalene triangle. Now, scalene means all the sides are different. Now, that's the third triangle right here, this third one, right? And that's where I paused. I'm a teacher. I think I'm pretty good at math. And I paused. And I looked at it. I looked at it again. And I'm like, huh? What? So the first 2, I'm like, all right, I got this. I got this. All right, I got this. The third one, here's what I'm thinking. Boy, that escalated quickly. I was like, what? So here's my challenge. This problem, that third one, right? This one right here. Can you see? I would like you to pause. Is there any idea? Miss Kresick, I think, is teaching this along with me. We're gonna pause our video and we're gonna see if anybody has any idea what we could do on that crazy little triangle right there. Doesn't look so difficult, does it? But look a little closer. I'm pausing now. See if anybody has an idea of what to do here. Okay, we're back. That escalated quickly. Did you have any ideas, anything at all about how to do this? Because I'm looking at this one and I'm just like, okay, I need to figure this out. And I'm just going to walk you through what we could do. And I think maybe this is a challenge. Like, I'm going to show you how to do it. And then I'd like you to see if maybe this is something we come back to next week and think, can we remember how to do it? Or maybe it's something you challenge. You got somebody in your family really good at math, take it to your mom, your dad, your auntie, your uncle, your grandma, your brother, and say, can you figure this one out? Because I think this problem is pretty tricky, right? I'm gonna show you how to do it though. We're gonna talk about it. It's a pretty cool problem actually. So what I want us to do is remember, do you remember how I said if we want to figure out the area of this one, we can just kind of complete it. So the idea of cutting it in half is we complete it into a rectangle and cut it in half. Okay, that's all well and good. Great job. Fantastic. But what do we do when it's all crazy? And when I say all crazy, what I mean by that is this thing doesn't line up with anything. It doesn't go, there's no 90-degree angles anywhere. I don't see a base and a height. Like I can do a height right here, right? That's fine. That's 90 degrees. But I don't know what this distance is. Like that's really hard to figure out. I don't know what this distance is. That's really hard to figure out because they're not on the grid, right? So all of this becomes very tricky. So what I'm going to do instead is watch this craziness, guys. Remember, that escalated quickly. We are going to take this corner and we are going to take this corner and we are going to connect them into a rectangle. So watch this. Watch this. I'm drawing my rectangle. And then I'm going to draw a rectangle here. Now, this is a strategy, which is a very interesting one, and it'll take me a little bit of time to describe it, but it is pretty cool. I drew that triangle right there. Now, that triangle, because it's along the 90-degree angle here, I can figure out, right? I can figure that one out. So now, this right triangle I can figure out. I'm also going to do the same thing. I'm going to extend my box down this way, too. I'm going to draw a line from here down to there, and from here over. Now look at this craziness. I just want to point out this craziness. First of all, how big is that box, that square? Well, down here, I have a base of 10. Just believe me, you can count it, but it's 10 units, right? It looks like an upside down 10, but 10 units. And over here, I have a dimension of 8 units, right? Okay. And if I count, I start at 0 and I go 1, 2, 3, 4, 5, 6, 7, 8. Down here, start at 0, 1, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the entire box, the whole thing, is 80 units square. So 80 square units. Okay, that's fair. We can do that. Now, once again, think about how could we break this up? So one thing that you might start to notice is that the first one, and I always mix up the colors, the first one that we drew, this one over here, right, this triangle, is a right triangle, right? That's going from corner to corner. It's exactly half of the whole thing. So that means that this must be 40 square units, right? Isn't that interesting? That means there's 40 squares in there. If I made all these into squares, there'd be 40. That's interesting. That's a strategy. That's something. I just got rid of this. So what am I looking for? I'm looking for this triangle in the middle. But I figured out that that one's 40. Now, can I find any other right triangles that I can draw? So we're going to change another color. Let's go to this blue. And let's draw this line right here. Now, I want to make right triangles. So what if I draw that one? What is the dimensions of this right triangle, right? So I look at this and I say, well, the whole thing was 10, so this one must be 9, right? And this one clearly is 3. So what's the dimension of this one? Well, 9 times 3 is 27. Half of 27 is, it's not too hard of a problem, 13.5 squares. Okay, half of 27, 13.5. Hopefully I did that right. Now, I'm going to find another little right triangle. Check this out. What about this one over here? Isn't this also a right triangle? Isn't this fascinating that you can do a problem like this? Can't I also take that one out? So this one is 1, and then I know the whole thing's 8, so that means this top part must be 5. 1 times 5. You see that? So I start here. 1, 2, 3, 4, 5. A little complicated. Goes all the way up to this point, right? That's 1 and 5. So the area of the purple one, right? I'm going to draw in a little thing here, must be 2.5 square units. Okay, we're getting somewhere now. I have 13.5 down here. I have 2.5 up here. And then the last bit I have are just these ones over here. So I'm going to draw those. Let's do those in black. I'm going to say, well, what about these last three squares? Here's a square, 1. This is just squares, so this is easy. 2 and 3. Now, what I wanted to know was how much area did I have in here, right? We haven't figured any of that out yet, but what we've done is we've figured out everything else, right? We figured out all the rest of it. So all the rest of it is, if the whole thing was 80, remember this? This is the entire thing, right? So now I have a little problem to do, or a little calculation to do. I'm going to say the total, right, of the rectangle was 80 squares, right? Squares. And I'm going to take away all the rest. I'm going to take away the pink. Let me make sure we get this. We're going to take away 40 minus 40. We're going to take away the blue, the light blue. Which blue was that? Was it this one? Minus 13.5. We're going to take away the purple. So where's my purple? Minus 2.5. Notice I'm lining up the decimals, right? And then I'm going to take away the 3. The 3 is my 3 squares. So also minus 3. And now we're going to calculate what that is. And I'm going to do some mental math here, kind of go step by step. I know that 13.5 and 2.5 together would give me 15, 16. 13 and 2 is 15. 0.5 and 0.5 is 1. That would be 16. I know that 16 and 3 is 19. And I know that 40, 80 minus 40 would give me 40. So I'm basically doing 40 minus 19. And 40 minus 19, 40 minus 20 would give me 20. So the answer must be 21 square units. Now, isn't that wild that you can do it that way? 21 square units is the area of the triangle, area of the triangle, right? Wow. Hard problem. And awesome, but also wow. I think that's fascinating, right? So what did we do? We made a rectangle around the entire thing. We eliminated, we made right triangles out of all the things we could, figured out the area by cutting them in half. I hope I did it all right. I hope so. And then we found these last few blocks and took those out. And now all together, we found out what's left. It's like a subtraction problem. It's like I know what the whole thing is, and I take away all the other parts. Totally fascinating. Okay, now I'm going to show you the other part of the problem really quickly. At the end of this problem, when you're on this page, right here, I ask you to open up the drawing, and I ask you to use the line tool to draw a right triangle with an area of 12 square units. This is a right triangle. So I'm going to take the green, and I'm going to start to put these on the map. Now notice I can just put these from dot to dot. So that green line, I put wherever I want. I can just change it. Like if I wanted to make it a right triangle, look at that. I'm just making it. I put that one on there. I'm going to make it 12 square units. So you figure out where the lines want to go. But basically, you are just taking these lines and manipulating them to be what you want. And then for the second one, and I would do the first triangle over here. The second one, the red one, is make another triangle with 15 square units, but this one cannot be a right triangle. So I want this one to be more like the second triangle that we did, something that's not a right triangle. Okay, see what you can do. This is all part of the Mars task today. Enjoy it. And wow, this problem right there. Wow, that escalated quickly. Craziness. Okay, have a good one, guys. Enjoy this problem. Make some nice triangle drawings for me. Remember to explain how you did it. I hope you all have a wonderful Thursday. Oh, and Khan Academy on triangles and parallelograms will be assigned. I think as of Wednesday night it's assigned, so it's due on Friday or Saturday. You can mostly work on it on Friday, but just want you looking out for that. All right. See you later, kiddos.